Welcome to Stage 6, Permissions, where 5 small letters unlock one of the most important ideas in Linux. Meet Mia. She just wrote a deploy script, typed deploy.sh, and Linux fired back, permission denied. But the file is right there, she owns it, she literally just wrote it. So why won't it run? The answer is chmod, short for change mode, and over the next few minutes we're going to figure out exactly what that means. Before Mia can fix her problem, she needs to read the language Linux is speaking. Every file carries 9 permission bits, shown as rwx, and the trick is that those 9 characters split into 3 triplets, one for each audience: the user who owns the file, the group, and everyone else in the world. Within each triplet, the letters always mean the same thing: R for read, W for write, X for execute, and a dash simply means that permission is denied. So let's give Mia her first win. Looking at deploy.sh, the permissions read RWR, R. She can read and write it, but nobody has an X, which is why Linux refused to run it. Now watch the fix. chmod +x deploy.sh. That little +x says add execute permission, and instantly LSL shows rwx xrx. The script runs and deploy starts. The plus adds, the minus removes, and equals sets things exactly. Simple, symbolic, and readable. But here's the thing. Plain +x just handed execute permission to everyone on the system, and Mia probably didn't mean to be that generous. That's where letter prefixes come in. U for the owner, G for the group, O for others, and A for all. So chmod u+x gives execute to just Mia, GW strips right from the group, and ORR resets others to exactly read, nothing more. And you can stack them with commas in one command: precise, intentional, safe. Now, once Mia gets comfortable, she'll start seeing pros write things like chmod 755, and that's just a faster shorthand for the same idea. Each digit encodes one triplet using simple math. Read is 4, write is 2, execute is 1. Add them together and you get a single number per group. So 755 means the owner gets 7, that's read plus write plus execute, while group and others each get 5, which is read and execute. 3 patterns cover most of your week: 755 for scripts, 644 for regular files, and 600 for private things like SSH keys. Speaking of 600, let's see it in action. Mia just generated an SSH key, and by default its permissions are too loose. Group and others can read it. SSH actually refuses to use a key that's exposed like this, which is a great built-in safety check. So she runs chmod 600 on the key file, and now only she can read or write it. She tries the connection, the server welcomes her in, and her secret stays secret. Now a warning. When permission errors get frustrating, you'll see advice everywhere telling you to just run chmod 777 and move on. Please don't. That's rwx. Every user on the system can read, write, and execute the file. On a shared server, that's a security disaster waiting to happen. Instead, diagnose first. Ask, who actually needs what? Usually 755 for scripts, 644 for regular files is plenty. Set permissions with intention, never lazily. Chmod doesn't work alone. It has a family of related commands. Before you change anything, LSL shows you what's already there, so you're never guessing. Chown handles a different question entirely, not what the owner can do, but who the owner actually is, and amass quietly sets the defaults for every new file Mia creates from now on. Together, these 4 cover the full permission lifecycle. Now it's your turn. 3 quick exercises, about 3 minutes total. Start by creating a test file in your home directory, then check its permissions with LSL so you have a baseline. From there, try chmod +x to add execute for everyone, then 644 for the classic file pattern, owner writes, others just read, and finally 600 to lock it down to owner only. Watch how the permission string changes each time. That's the fastest way to make chmod click. And just like that, lesson 26 is complete. You've learned the RWX system, symbolic shortcuts like chmod, Octal notation like 755, and why 777 is the lazy disaster to avoid. Next up, chown. If chmod controls what users can do, chown controls who owns the file. Together, they give you complete control. See you in Lesson 27.